It is that time for me to do some problems and you to love homework so much that you would like to watch them. So we're going to start with number 6 in the book. All right. Number 6 in the book says, expand each logarithm as much as possible. Log base 4 of x over z over w. And it wants us to expand this as much as possible. We're going to use the quotient rule. You could simplify the inside first, but you don't have to. Quotient rule says is the log of the numerator minus the log of the denominator. And then we can use the quotient rule again. Log of the numerator minus the log of the denominator. There we go, fully expanded. If you combined this initially, you'd have gotten x over zw. And then again, everything that's in the numerator gets a plus. Everything in the denominator gets a minus. And you can use the product and quotient rule that way as well. All right. Next up, look at number 12. Number 12 from the book says, condense into a single logarithm ln a minus ln d minus lnc. Everything with a positive is going to be on top. Everything with a negative is on the bottom. You could also do this in multiple steps. First, use the quotient rule on the first two. Becomes the natural log of a divided by d. Natural log of c is still there from before. And then this subtraction means that c also goes on the denominator. The natural log of a over d divided by c, quotient rule again, and then simplify the inside to get the natural log of a over cd, or dc. We usually put them in alphabetical order, but this is d and then c, so it's all good. That's our answer. Let's do 24. Condense to a single logarithm, and it's going to be a little bit messier. 4 log base 7 of c plus log base 7 of a over 3 plus log base 7 of b over 3. This is almost identical to the last one we did in video 4. In fact, it's just different letters and a different base, but we'll go for it for review. We use the power rule on this first one to get log base 7 of c to the 4th. And the other ones, we remember that dividing by 3 is the same as multiplying by a third. Oh, and this one is also positive. The last one was negative. And now we can use the power rule again. 1/3 goes into the exponent. We get log base 7 c to the 4th plus log base 7 of a to the 1/3 plus log base 7 of b to the 1/3. Now we can either use the product rule or rewrite these exponents as radicals. Right? An exponent of 1/3 means the cubed root. And we get something like this. These are all added together, which means they all get multiplied together on the inside in a single logarithm with a product rule. C to the 4th, cubed root of a, cubed root of b. And if we multiply two radicals together, as long as they have the same index, we combine them under the same radical. And we get this single log as our answer. For 28, this is again, suppose log base 5 of 6 is a, and log base 5 of 11 equals b, And we're trying to simplify log base 6 of 55. So again, we have the wrong base. We can't use any of these properties unless our bases are the same. So our primary goal, our first thing we need to do is use the change of base formula. Change of base formula says that as long as we divide, we can change the base to whatever we want. So let's change it to log base 5. Because in order to use these properties, we need a base of 5. And then we divide by also log base 5, but this time take it of the base. Well, log base 5 of 6. That is exactly A. Right? That's the red thing. Log base 5 of 55 in the top. Now that's going to cause a problem. Did I write the problem down right? Log base 6 of 55. So we did log base 5 of 55. We want to write this in terms of 6 and 11. Oh, I see. This one's tricky. So we can't write this in terms of 6. Right? 6 has nothing to do with 55. But we can write it in terms of 11. What's the relationship between 55 and 11? It's just 5 times 11. And my gut says this isn't helpful because we need a 6 and an 11. But 5 is also okay. Why is 5 okay? Because 5 is the same as the base. So that'll get simplified as well. Oh, that's good. That's pretty tricky though. So product rule says this is log base 5 of 5 plus log base 5 of 11, all divided by A. Log base 5 of 5 to the first power, use the inverse property. They cancel each other out. We're just left with that exponent of 1. And the second thing, log base 5 of 11, that's exactly B. 1 plus B over A is our final answer. Or you could write it like this if you wanted. I like our version more. But you could also use this. It's a good problem. I like that one. Let's do 32. Use properties of logarithms to evaluate without using a calculator. 2 log base 9 of 3 minus 4 log base 9 of 3 plus log base 9 of 1. Was that 729? Yeah. So we could just evaluate each one of these logarithms separately, but it's going to be a little easier if we combine these. And then we only have to evaluate one logarithm. It's 2 birds with 1 stone. We get to practice using properties, and we only have to do 1 logarithm instead of 3. So it's going to be easier if we combine first. What happens if we do that? This becomes log base 9 of 3 squared. Use that power rule. 3 squared is 9. Minus log base 9. Power rule again. 3 to the 4th power. 3, 9, 27, 81. Plus log base 9 of 1 over 729. And again, if you want to right away say that, hey, this is 1. This is 2. This is something. You can. There's a bunch of different ways of doing this problem. But I'm going to just get some practice combining. This becomes the log base 9. This is positive. It goes in the numerator. This logarithm's negative. Negative goes in the denominator. And then this one over here is positive, but it's already a fraction, so we're multiplying it by 729. All right, maybe this wasn't easier to combine it first. Did I write the problem down right? Yeah, I did. All right. Well, let's just write everything in terms of threes, or in terms of nines, right? This is 9. This is 9 squared. What's 729? Is that 9 cubed? 9 squared is 81. Cubed, yeah, is 729. How do we simplify this inside? We have 9 to the first on the top. Combine the bottom to become 9 to the fifth. Just 9 to the negative fourth. Inverse property says our answer is just negative 4. A lot of different ways of doing this problem. All right. This one is a good way for practice, but it actually turned out to not be as easy as I thought it was. Here, let's hide this. Nobody saw that. We were just doing that for practice. All right. And that's one of the interesting things about math in general, right? Sometimes you think, oh, this is going to be easier if we do it this way. And you try it and you go, nah, there's an easier way. Experience helps with that. But as you can see, it's not foolproof. Use the change of base formula to evaluate as a quotient of natural logs. Log base 4 of 15 over 2. Wants us to use the change of base formula to write as natural logs, and then use a calculator. Change of base formula says we can change it to any base we want as long as we divide. So instead of log base 4 of 15 over 2, it's the natural log of 15 over 2. We just have to pay this little penalty of dividing by the natural log of 4. We can type this into a calculator and get our answer. Natural log of 15 halves divided by the natural log of 4. About 1.4534. Check our answer with a calculator. Log base 4 of 15 halves. Great. They're the same thing. And that's properties of logarithms. I cannot stress it enough. It is very important that you are very confident and comfortable with these properties without having to check the properties list every time. It's going to really help if you have these internalized. They don't have to be memorized, but getting them memorized is really helpful because then you don't really have to think about them anymore. Just like we don't really have to think about a lot of other simpler things like addition and subtraction anymore. Makes it a lot easier to work with these as we go into the future sections in chapter 6, all right? Good luck, and let me know if you have any questions.